Hello everyone, I am Sneha Mandal and today I am going to present my internship project which is real-time electric vehicle and ADAS warning system which I have completed during my 1 month internship. So what's the purpose of this project? I have designed this dashboard, embedded dashboard which will monitor important electric vehicle parameters and also provide advanced ADAS which you can say advanced driver assistance system and safety warnings. This project combines a lot of things, which is sensor integration, UART communication, and dashboard visualization, which will help in improving vehicle monitoring and safe driver safety. So let's go to the next slide. So why do we need electric vehicle and ADAS system? as we as we all know that nowadays modern electric vehicles generate a large amount of information such as battery voltage, temperature, speed, electric energy consumption. If this information is not monitored properly, it might lead to a lot of battery degradation, overheating, or unexpected failures. And as we all know that advanced drivers assistance system helps us in improving road safety by detecting nearby obstacles and alerts the drivers before any collision happens. So, combining the electric vehicle telemetry with ADAS warning into a single dashboard, which will make uh, vehicle monitoring much safer, smarter, and easier for the drivers. So, let's go to the third slide, which is system architecture overview. So, this project is into four stages, main stages. First stage is simulated inputs. Second is STM32 blueprint. Third is UART telemetry. And the last, Python dashboard. So the first stage is simulated inputs. So what is simulated inputs? It generates parameters, like battery, voltage, speed, temperature, ultrasonic sensor readings. Second is STM32 Bluepill. It is a microcontroller which will process all sensor values and runs the safety algorithms. Third is UART telemetry. The process information is transmitted through UART communication, which will act as a communication bridge between the controller and the dashboard. And finally, Python dashboard, which will receive this data, displays it graphically, and shows the warning messages when whenever any abnormal conditions are detected. So let's go to the next slide, which is the 9 phases of this roadmap. This project is built in like multiple phases. Initially, we have configured the STM32 controller, GPIO pins, UART communication, and sensor inputs. Next, we have implemented the vehicle logic, including uh, bat including battery monitoring, speed calculation, ultrasonic distance measurement, and fault detection. Then UART communication is built so that real-time data could be transmitted continuously to the dashboard. And finally, the Python dashboard is developed to display the live telemetry warning messages and fault detection. Then the UART communication is built so that real-time data can be transmitted continuously to the dashboard. Finally, the Python dashboard is developed to display live telemetry, warning messages, and graphical indicators. So let's go to the next slide, which is ultrasonic ADAS safety engine. This is like one of the important part of this project. Ultrasonic sensor will continuously, measure the distance between the vehicle and the nearby object. Based on that distance, different warning levels are generated. If the obstacle is far away, the dashboard will display a safe status. If the object comes closer, warning message becomes more critical, and when the distance becomes very close, or you can say danger is small, an emergency warning is displayed to alert the driver immediately. This feature will, you know, helps in reducing the collision risks more, and we can say the ultrasonic sensor will trigger forward collision warnings when it is below 50 centimeter, blind spot detection, time to collision, parking assist. Uh, these are the features it will show. Let's go to the next slide, which is fault registry and alarms. This project will show different fault conditions, which includes low battery voltage, high motor temperature, obstacle when detected within a dangerous speed, communication failure. Whenever any of these faults occur, the dashboard immediately displays a warning message, and at the same time, the system will perform safety actions such as reducing speed, activating warnings, and entering safer operating mode. We have included fault flags as we can see here. 01, is 00, which is fault null. 01, which is fault OT. It will show when motor overheats. Fault SOC, which is 02. It will show state of charge draining. Fault collision, which is 03, which will show when a collision occurs. So let's go to the next slide, which is UART telemetry and commands. STM32 continuously transmit packets containing battery, voltage, speed, temperature, ultrasonic distance, warning status, and fall information. The Python dashboard receives this information in real time and updates the graphical interface instantly, which is achieved because of UART protocol, which helps in the communication between the controller and the dashboard. Let's go to the last slide of this presentation. So, so I have learned a lot of things when building this project. I have learned how to program an STM32 microcontroller, uh, learned how to figure out UART serial communication, designed sensor-based monitoring system, implemented safety logic, developed a real-time dashboard using Python. So let me close this presentation and show you the STM32 workspace. This is the workspace I have developed. Mm, You can see the project here, EVDAS. This is my main code. You can see, I have included flags here, sensor flags, speed, SOC, motor temperature, and a lot of things. You can see here I have included the collision, blind spot, left and right, and let me show you the IOC configuration. As you can see here, it is IOC pinout and configuration. You can see it here. These are my C files and my header files. You can say the source files and the header files I have included here to build this overall project. This is my workspace. Let me show you my Pixim lab. I have used this board Blue Pill microcontroller STM32F103C86, and I have used the serial COM1 with the baud speed 1115200. You can see my spare parts here. This is my potentiometer, my ultrasonic sensors, where I can see, my front, right, left. These are my LEDs, and you can see the virtual terminal where it is printing all the results. And this is my command prompt where from where I have you can uh, use to develop this Python dashboard. You can see here my speedometer, my battery, and the car, which is showing the bird eye interview view. You can see the torque, which is minus 29 nm, acceleration, brake, motor temperature, alarm, fault, which is 00, signal, which is on. My brake is 53 percentage. Motor temperature is showing 29.9 degrees Celsius. Here, when you know, let me show you. When I decrease this, we reduce the front collision. When it is below 30, you can see the red l- light is turning on. My fault detection is on. Fault is getting, yellow, turning on. And then let me show you the Python dashboard. As you can see, it is showing critical. It is giving me a warning that the obstacle is very close. And this is how, uh, let me just increase this. And you can see it here. So yeah, this is my overall project. Thank you.